Okay, I believe I've got the recording started. According to the icon, I've got my screen shared with Alex and Desmos ready to go. Welcome all of you who have joined the session. I will, let me see, I need to make sure I've got my chat window open and my participant window. For some reason, I'll have to check my settings, but I have to admit people as they come in. So I'll try to keep watching that. So I'll watch introduce myself. Most of us have not met. I'm Dr. Mike Little Crow, and I'm here to work with you on preparing for any questions you have on the to get ready for the algebra exam. It's been a long day already, but we're here. So what I find first of all, the thing we want to focus on is the topics that are in the review module, the reviews. So there's 4 different reviews: 1 to 3, 4 to 7, 8 to 11, and then 12 to 14. Those topics that are in those reviews are what are used to make up your 20 question exam. So if it's not in the reviews, it won't be on the exam. Not necessarily everything in the review will end up on the exam, but you get basically the same topics. There's a couple that are doubled up, and you'll get 20 of the topics from the reviews on your particular exam. And there are there are solution videos for each of the questions. If you've had some struggles, hopefully you've been able to review those. What I'd like to do is, as you have any, just basically open up to questions. I am recording this, so I will post this as an announcement as soon as we finish, or as soon as it processes, then I can do that. What I find to be most helpful is questions that tie back to a particular topic in one of the reviews. We can find one, work through a problem, but I'm here to answer any questions you have. So let's go ahead and get started. If it's easier for you, you can post something into the chat. I'll be watching that, or just unmute yourself and let us know what you'd like to see. Question. Who's got a question? Oh, does anybody, let's see, had my volume down a little bit if anyone was talking. Yes, hi, Abdullah.
Okay, so yeah, I was thinking, you said, I thought you were coming with maybe a specific topic, and then you can ask, or anybody can jump and ask like immediately.
Yes, any particular, we can focus on any of the review modules. Again, 1 through 3, 4 through 7, any of those 4, because that's where the exam questions are going to come from. If you're still working on the modules themselves, the homework, again, we could pull one up as long as it's on the review. If it's not on the review, it's not going to be on the test. So we could maybe deal with that at another time. But yeah, this one we really want to just focus on those reviews, because those are the only topics that will be on the test. And we have our limited time here. So
Okay. I think I have hard time on polynomial function.
Okay, we had Lizzie wanted something from module 4 to 7. So let me go ahead and pull that one up.
Okay.
And then if just for sakes, if you find any questions in here that you'd like to see, it's always easiest for us to kind of just deal with a module or a review at a time.
Oh.
And then we could, because jumping around, we lose a little bit. So what in particular, so we've got questions on transformations. There's 14 questions in total. Area using quadratic function. Oh, something like this, number 14. Building a garden and area. Okay, perfect. Almost like we read each other's minds or something. Anyway, you put me this way. And hopefully everyone can hear okay. Let me know if the sound is not so good. I'm in my office so that I've got fairly stable internet here. When I go home, it's not always stable, but I think I should be good here. Let me, oops. This is actually not my office, it's just a background that blocks some of the glare. Okay, quadratics. Now, let's see, get everything working here. So we'll just start with this one. Hans wants to build a fence for his rectangular garden. He has 120 meters of fencing, so that's going to be one of our constraints. Suppose that a side length in meters of the garden is x as shown. So they show an x here, which means this side is also x. And then the questions are that we want a function that would give the area, and we then want to find the maximum area. Okay, so area is going to be length times width for a rectangle. So the one length times, and what we have is we have one side that is x. So our formula for area will be equal to x times this other side. And so what we want to be able to do is say, what is this other side? Well, we could just call it y, or anything else. You could call it w, but we're just going to give it a temporary label. Since we only have 120 meters, the two sides that are length x, that's going to be x plus x, right? So those will be 2x plus the y, actually 2y, right? There's a y up here and a y down here. So those two sides together are going to be 120 meters long. What we want to do is we actually want to solve this for y so that we get this side in terms of x. Okay, so we would then subtract 2x from both sides. Leaves us with 2y equals 120 minus 2x. And then we divide both sides by 2. And actually, I'll just divide everything by 2. And we end up with y equals 60. That's half of 120 minus x. And so our area is really of this garden is going to be x times y. But now we can substitute y as 60 minus x. So that's x times 60 minus x. We can distribute through area. So our area, I don't know why I keep writing that R, area. Distribute through, we're going to get 60x minus x squared. and that's going to be the function for this that would give us the area in terms of x. Okay, so far does that make sense? Any questions on that part? Okay, so in here, I'm going to go ahead and type that in. I forget, I got multiple things going on. Maybe I don't really need this one. Take that out. We would just put 60x minus x squared. That would be that answer. Then what side length of x gives the maximum area that the garden can have? So for this one, we're looking for the vertex. Remember with x squareds, with quadratics, they always graph as a U-shaped function. So they will be, I'll leave it, again, it'll graph either like this or like this. Since there's a negative in front of the x squared, it'll look like this. So the maximum occurs at the vertex. The x-coordinate of the vertex will give us the side length, and the y-coordinate will give us the area. So in one fell swoop, we'll get it. All we need to do now is graph the equation we came up with, the function we came up with in Desmos, 60x delete those out of the way. 60x, actually, let's do y equals 60x minus x squared. So we can enter that into Desmos. And you all know that Desmos is the calculator we use in online classes. So it's available to you throughout the exam. And we see a line being drawn, the red one. What we need to find is the top. And so just pull it over, maybe zoom back out a little bit, and we will see, okay, there. Now it's starting to look like a quadratic. It's just going up really high. Another way you can kind of do the settings is you can come here because we're going too far out in the x and we need to go up higher in the y. We know we want the maximum. I'm going to do my y-axis from 0, and I'm going to go to 1,000. It looks like that's not quite oh, that's 100. Here's 1,000. So now I see the top of the graph. The x's, remember x is the length of a side. It doesn't make much sense for x to be negative, so we'll go from 0. And the whole thing is 100. The fence is 120. It couldn't be longer than 120. In fact, it's going to be much less. So now we got a fairly good view of this equation. All we have to do is click there, is click on the vertex, and it tells us right now that if we make that one side x, if we make it 30 feet or meters, whatever units we have, we will get the maximum garden size of 900 square feet. Okay, so we come back over here, it's meters. The side length that gives the maximum area is going to be 30, and the maximum area we get is 900. Okay, and we get that just from the graph, and that's all we have to do. Now there's some formulas you could use for the formula for the vertex, but that's more work. I would highly recommend using the graphs and finding those values just from here. Does that help with something like this, finding the area in a word problem, getting it down to one variable, just in this case just x, using the perimeter, getting a formula, and then finding the maximum is going to find the vertex, graph it, and then just click on that vertex and you'll get your maximum, remembering x is the length of the side, y is the area. All right, excellent, excellent. I'm going to clear this off. And the other thing is, oh, no, it's these over here. That's why I did that. So maybe that's helpful at times. Okay. What's next? And again, this is here for you to ask any questions. All the videos, all the topics in here have recorded solutions. Of course, when we pull them up, we can potentially get different ones, and that's why it's really helpful to work through these multiple times. Let's see, we've got something over here. Polynomial and rational functions, topic name, determining the end behavior of the graph of a polynomial function. We've got an example here of f of two different functions. Polynomial rational functions. Let me see if I can determining the end behavior of the graph. Okay, so let's do this. So end behavior. Look at the first one. So analytically, end behavior is determined by two things. One is the degree of the polynomial. So this is an odd degree, which means it will behave either like this. So it comes from negative infinity goes to positive infinity, or it will behave like this, sort of in reverse. And I'm going to graph these so you don't necessarily have to memorize these. And I don't know exactly how this one will look, but notice when x is negative, the y values are shooting down towards negative infinity. And when x values are positive, the y value is shooting up towards positive infinity. So this would be the case of this one. It would, the end behavior, and again, I don't have the question, so I don't know exactly the format it wants it in, but we would say with this one is that since it's got a positive leading coefficient, as x goes towards negative infinity, y is going towards negative infinity. As x goes towards positive infinity, y is going towards positive infinity. Okay, and again, you can see that by putting it in to decimals. So you don't even have to memorize these things or even necessarily know, but and while all of this other stuff behind here does help determine what the graph ends up looking like, the 4x and then the -4. You see it's got that kind of coming from down to up. So it's I call it the swirl cactus with one arm up, one arm down. And so again, it's we would say for end behavior, as x is going to negative infinity, f of x goes to negative infinity. And that's because of this thing here is going down as x is going this way. And then as x goes towards positive infinity, which is over here, the function values are going towards positive infinity. Okay. Go ahead.
And here. Yeah, after that, function a is saying fall to the left and rise to the right, rise to the left, and fall to the right, rise to the left, and rise to the right, fall to the left, and fall to the right. So 4 choices I see here. So this is falling on the left and the right on the right side.
I'm not. Yeah, I mean, you could say as well as x goes to the right towards infinity, but this is. I mean, we could look up the question, but they'll have a format for how the answer needs to be formatted. But that's when we're talking in behavior, we're asking what happens as x either goes towards negative infinity or positive infinity, what's happening to the output variables. Okay. And in the second one we have there, let me clear this out. The second equation, again, because it's x to the sixth, which is going to be, so actually I'll just go ahead and type that in here. And it's negative x to the sixth plus 6x to the fourth minus 7x minus 8. 6x to the fourth minus 7. Oops. And again, because it's to the sixth power, it's going to be either a U shape up or a U shape down. And we see in this case, it's a U shape down. So in this case, in both directions, as x goes to negative infinity, the function value, the output, is also going to negative infinity. The y value is going to negative infinity. As x goes towards positive infinity in this direction, the function value is going towards negative infinity as well. They're both going down. Okay. And again, yeah. And it's easiest if you can find one of the review questions, then we can look at them, because sometimes they ask multiple things and we can make sure we're getting everything answered, because on the exams come up with these topic questions just as they are in the reviews. Not, again, there's a question bank, so there's a lot of things that you can work with. So Marquis, is the second question, the composition of two rational functions, was that from one of the reviews?
I believe so.
Okay, so let's take a look. two rationals. Okay. So this is 4 through 7. If it was in mod 6, it would be in one of these. I'll go ahead and do it since there's no other questions coming up, but it might not be, again, if it's in mod 6, module 6, the only ones from module 6 that would be in the test will be these ones on the reviews. So I just want to emphasize that so that, and it's not that I don't want to answer questions on anything else, but if it's not on here, it won't be on the exam. Two rational functions. So we have f of x equals, and is the x plus 2, is that all in the denominator? Or is it 5 divided by x plus 2?
It is 5 over x plus 2.
Okay, very good. And g of x, 13 over x. And then we're supposed to list the domains as well. Okay, so we could do, and I'm not sure if this one wants both compositions, so f composite g of x. The one that's closest to the x is the one that's the inner function, so this is really f of g of x. So what you're doing is you're plugging the g function. I'll do that in red.
Excuse me.
Yes.
The g of x should be 5 over x minus 1.
Okay.
I'm sorry.
It's okay. Oh. Like that?
Yes, that's correct.
Okay.
Thank you.
Okay. So the way we're doing is think that f is going to receive g into it. So this all goes in for the x. What I like to do is take what I call the outside function, the one we're starting with is f, change the x into a symbol of a big parentheses, big open parentheses. So I read this as 5x plus 2. Notice it's really the same thing, but now I have space to plug in the other function. And so in here goes the whole g function, 5 over x minus 1. That's the composition. And now what they're going to want us to do is simplify, because we've got a fraction within a fraction, right? So what we do is we multiply the bottom by x minus 1, which is the denominator of the g function, and we multiply the top by that same denominator, because x minus 1 divided by x minus 1 is just 1. When you multiply by 1, nothing happens. 5 times 1 is 1. 10 times 1 is, 5 times 1 is 5. 10 times 1 is 10. So multiplying by 1 does not change anything. So what we get, I'll do it this way. I'll do the numerator first, and then we'll get to the denominator. You'll see how it cancels. So 5, so we take the 5 and distribute it. When we multiply, we're going to get 5x minus 5. in the numerator. In the denominator, we'll distribute this over to here. You get x minus 1 divided by x minus 1, which will cancel out. And in the denominator, for this first term, all that would be left is 5. And then we distribute the 2, you'll get plus 2x minus 2. 2 times 1 is 2. That makes this. Are you following along so far, or did I miss that? I lose anybody in that?
I'm following along.
Okay, great. And then we just simplify. We end up with 5x minus 5. 5 minus 2 is going to give us 3 plus 2x. So this would be the answer for the function, for the composition. We have two things we have to do for the domain, though. First of all, we have to check the domain on the inside function. So g is on the inside. The inside function, x minus 1, cannot equal 0. So we set it equal to 0 to find what we have to take out of the domain. You add 1 to both sides. And the reason is division by 0 is undefined. So if x is equal to 1, we will have an undefined thing. So that is not in the domain. And then the second thing is, after we do all this stuff, we end up with this function. So 3 plus 2x also cannot be equal to 0. So we're going to solve this for x. Subtract 3. 2x equals negative 3. Divide by 2. We get that when x equals negative 3 halves, which is 1 1/2, that also would be undefined. So the two values we need to remove. I'll do a number line. Here's 0. Here's negative 3 halves. It's about 1 1/2. And here's positive 1. Doesn't have to be real accurate. But what we know is we need to take out negative 3 halves from the domain, and we need to take out 1. Everything else can be in the domain. So this is negative infinity here, positive infinity on the number line here. Again, we can have everything except negative 3 halves, and then in between we can have everything until we get to 1, and then on the other side of 1 we can go all the way to infinity. So for domain, come up a little bit, see if I get more room. Not much room. It's going to be negative infinity to negative 3 halves union negative 3 halves to 1, parentheses on both sides, union 1 to infinity. So that's one part of the answer would be the function. The second part of it would be the domain. And again, you've got to remember to check both those, both the input function itself and then the final function. Questions? Is that helpful?
Yes, thank you, sir.
Okay, welcome. All right. Again, we can jump to any of the modules, any of the reviews you need to take a look at. If you have questions about the exam in general, anything you have a question on, please feel free to ask it. Stick it in the chat. Oh, I see. I was typing down here. And just remember the way I have these set up is that the exam is due on Friday at 11:59. There is a no penalty extension, a 2-day extension until Sunday night. Now, some say, well, why don't you just make the due date Sunday night? Well, you could think of it that way, but at the same time, if you get it done by Friday, the way we've got everything planned is that weekend then is open to start on the trigonometry. So we want you to get through. Okay, scratch paper. As you do it, there's a place in Canvas. It's called the Algebra exam random. If you click on that, that's an assignment. That's where the score from your ALEX course will, or ALEX, the ALEX test that you take, the score will go there. There's also in that assignment, you can upload your scratch paper. And what we have you do that is if you do that, after the deadline passes for the test, you will be able to review your questions, and there is the potential to request partial credit. Partial credit is something like you saw maybe on your scratch paper, you had some right work and maybe you put something in wrong. There's a lot of things that can happen, but by having the scratch work there, it's something we can review. It's not a guarantee, but it can help with getting partial credit. We'll go back and review things. Sometimes the way Alex assesses things, there might be two parts and you might have got one right, but not the other. And it gives you a full 0. And I'm able to look at that. Yes, in fact, Desmos is the only calculator. Well, yeah, both the Desmos and Alex. If Alex, we could only use online calculators. There was an issue over the last summer. Someone was doing some swiping, which doesn't really work for calculators. So they had a handheld device that was not a calculator, and it wasn't allowed, and it kind of got snuck in. So if it's online, it shows up on the recording. So yes, you could use the Desmos calculator. You can use the Alex calculator. Alex doesn't always give a calculator. That's why we allow the Desmos calculator. And actually, I've been using the Desmos. I wasn't sure if they were going to allow it. I just started using it because I thought it was the best. And you'll see when we get into the trigonometry, it does some things that the other handheld calculators, the TI-84, will not do. It'll give you the answer in pi format that Alex asked for. So yes, those two calculators are available, and I highly recommend, if you haven't done it yet, to do the honor lock test. You're supposed to do that, and part of that is there's 5 points in there. You're supposed to take a picture or a screenshot of your setup, because you're supposed to set your computer in such a way that it does capture your face, that the software wants you, but it can see your hands and what you're writing. You may have to put it up on some books or something. I've got a laptop too, and but find a way to set it up so that you can see your question, you can work on the question, and the camera can capture it. There's instructions in there for doing that. Well, it's the Desmos graphing calculator. So the one I had, let's see, where did it go? This one. So this is the one. Now, the thing is you can also use this calculator as a regular calculator. You say you want to find the log of base 3. Let's do this. It'll actually functions. You can calculate stuff in here. Here we go. Log. Here's the log base one. So actually, get rid of this. Let's say log base. Maybe there's a question in there with log base. Yeah, let's try this again. Go to functions. This was one people said, no, it doesn't have the log base. I said, yes, it does. It's in here somewhere. I passed it here. Log base, say 5 of 27, and you get your answer here. So you use it as you could use it as a scientific calculator as well. You just put in values without a variable. It's not going to graph it. It just gives you the value. And then you say, times 6, whatever the thing is, you can do it, and it will calculate for you as well. So the Desmos graphing calculator is the one we use, but it's more versatile than just the scientific calculator. And actually, if you want, additionally, the honor lock system itself has a scientific calculator built in. It's not as easy to use, but you could use that one. It's any of the online calculators that are available. So we provide 3 different calculators. I sort of plan to just stick with the Desmos because it can do everything. But
I'm sorry, I have a question really quickly.
sure.
I just wanted to ask, sorry if you went over at the beginning. I had gotten off work, so I wasn't able to make it at the beginning of the meeting, but is the exam curved, and how many are you able to tell us how many questions are on it?
Yes. There's 20 questions,
Okay.
and that's in the instructions.
Uh-huh.
And it's, if you get them all right, the 20 out of 20 is 100%. So that's,
Right.
that's, so there's whatever you score on it, that's what goes in.
Okay.
It'll actually get turned to 300. What I do is in the Canvas grade book, I do it out of 1,000 points, just so that each exam's worth 350, which is 35%.
Uh-huh.
So that comes right over. And but what we are able to do is you are able to review it, and I'll send instructions probably Saturday morning on getting partial credit. So you review it and you say, oh, there was 2 answers. I got one of them right, but I missed one.
Mm-hmm.
And you tell me to review it, and I'll take a look. And if it's appropriate, I give maybe half credit on that. And sometimes, anyway, there'll be the instructions will have it. So that there's a way of getting, so once you take it, the Alex will give you your score. So that's sort of a minimum. Once you review it, there's oftentimes, because I don't believe the computer is perfect at scoring things. So that's why I take a second look. But with all these students, what we do is we just ask you to take the first look and tell me which one of them, because you may look at one and say, oh yeah, that was off. I was waiting, I was guessing. I'm not even going to have you look at that one. So maybe you missed 3 and you have to look at 1 or whatever. But we want you to look at it first and then send in that request. And again, I'll give the instructions. You'll send it by email, and you'll just tell me which questions that I should be reviewing and why. And I'll do that. And oftentimes I find students will get an additional 10 points or more than that, but maybe I've seen some get as much as 10 percentage points that are, it's not that, I'm giving them away, but that's what they should have got, but Desmos didn't assess it that way. So
yeah,
we do that double assessment so that just to make sure we're getting you the maximum value that you're putting into it.
okay, thank you so much. Is it a mix of multiple choice and like free answer?
It is just like the reviews.
Okay.
So it is 20 questions taken from those reviews. So as you work through those reviews, there is also a practice test that's modules 1 through 14. That's 20 questions long. That will give you the feel of the length of the test. So you could take that. But I highly recommend going through each of the review modules, because that's where the test questions are taken from, and they are just like those test questions.
Okay, perfect. My last question for you is just, is the lecture recorded? Like, will I be able to go back and watch the module 1 through 3 review, or is it just the Zoom for today?
Well, the Zoom is here. So each question individually on all the reviews has a solution.
Okay.
So but that's in Canvas. And then let's see, let me pull that up. Yeah, I should probably show that. And this is being recorded too, so you could go back to the beginning of when we started. And
Oh, okay, perfect. Thank you so much.
Sure. And then just let me show everybody. Each review, if you hadn't clicked in them, so review for week 1, solutions for modules 1 through 3. So this also provides, tells you why it's important. These are where the test questions are taken from. And then there's these solution videos where I pulled up and I talked through each of these questions. So now when you go and take this, your question 4 will be a little different, but it will be from the same topic, finding a different quotient for a linear or quadratic function. So that's what I mean is you could go right through here. And if it's a module 1 through 3, but it's not in the review, it won't be on the test. So this helps you narrow it down from about I don't know, we're probably close to 100 topics. In the reviews, there's about 45, I believe. So it narrows down what you need to study.
Okay, perfect. I really appreciate your help. Thank you so much.
Pleasure. Thanks for coming on. And then we had a request to go over to modules 8 through 11 using graphing calculator to solve a word problem. So where's my module? What happened? Oh, that one. It's there. I think I lost. Oh, here it is. Yeah, I did. It got crunched together. Okay, here we go. So we're going to submit this one. And the other thing you may have found is that once you start working in a review module, and if you haven't, this is good information, you have to submit it before you'll be able to go back and do anything else. And like you could do a quick retake. Actually, I don't want to do that. Well, you can see the report. It will tell you what you got right or what you got wrong. Let's go into module 8 to 11 review. And even if it marks it late, there are no late penalties in my class. They're just kind of, what I did is use these they have a first due date and a secondary due date just to kind of show you where it's best to be at. So now we'd like to look at Caitlin. Yeah, if you can, I'll do this other one from module 8 to 11 first, and if you can locate that question for me, then we'll go there. So let's see. Using a graphing calculator, solve a word problem involving local extrema. Let's see. And again, we can go through these. If you can get me a question number from each of the modules, we can get there a little bit faster. Not that one. Graphing calculator, find all the zeros. Solve a word problem. It was the one with the box. Oh, it was. Okay, so this one. That's the one, Lizzie? Okay, very good. This is a very popular one, and there's one with the lid, which we got here. There is one that it doesn't have a lid, but it's sort of the same, similar approach. Okay, and it's similar to what the one we did earlier on with the quadratic, except this time we're going to get a cubic function. We're going to be looking for the maximum. Okay, so the picture out here gives us a box. We're told it's 5 inches. Let's do it this way. It's 5 inches by 8 inches, the length of the paper, the cardboard. And we're going to cut out some squares out of the corners, and we're going to cut this part out here. We're going to make some cuts, and then we're going to fold it up and make it into a box. Okay, so that's what all this is explaining. Letting X represent the side lengths in inches of the squares. So that's X is how much we have cut out. You need to come up with a function for volume. So here volume You have to remember it's going to be length times width times height. And they give you a little bit of hint in the picture that they've done out here that the height, this cut of x is actually going to be the height. So when we get the volume, the height is going to be x. Now we just need to figure out the width of the box and the length of the box, and we'll be able to get the function for the volume, and we'll be able to solve everything from there. The easiest one to start off would be this I guess we'll call this the width. It starts out at 5 inches, and what gets happening, we're going to cut this corner off here. We're going to cut this corner off here. This corner, the amount we're cutting off is x, and we're cutting off x here. So it's that length of the width that's going to be left along here is going to be 5 minus 2x. So the width of this box is going to be 5 minus 2x. And again, we're going to kind of play with what happens as you make x bigger or smaller. You're going to change the volume of the box. The other thing we need is the length, and that's going to come from the 8. So the length is going to starts out being 8. We're going to cut out this here. We're going to cut out this from the length, and we're going to cut this from the length. So we're going to cut out 3x. But the other thing is not all of this becomes volume for the box. Half of it, because we're folding over, will become the lid of the box. The lid goes in, it doesn't increase the volume. So by folding it in half, we're going to cut this, whatever this width is, the length, it gets folded in half, so it's only going to be half that much. And so the length part of this, so a little bit more room, and since I'm going this route, is going to be 8 minus 3x divided by 2. And that's the key part. You have to see that that's each side. The 8, we're subtracting 3 x's, we're cutting out the x 3 times, and then we're folding it in half. The width, we cut out 2 x's, we didn't fold it in half, so that's that. And then the value of x itself ends up also being the height of the box. So this is our function here. And does that make sense? Any questions on what I did there? Okay, so I'll keep moving, because after that, it's just, all we're going to do is graph it. And you're going to see, because it's x, it's going to be a cubic. And it'll look something like, what does it look like? I know this side goes up like this. Maybe this goes down like this. But we're looking for this maximum here. It'll give us, the x value gives us the cut. The x value that maximizes the cut will come from the x coordinate. The maximum volume will come from the y coordinate. Okay, so we just need to find that. This is what we put into Desmos, and we will get our answer. Or you could use the, we could use the Alex calculator. To me, it's a little harder to use. Let's see, y equals, what did we have? We had 8 minus 3x. I'm going to highlight this, and then I'm going to do the divide button by 2. And then we're going to multiply, what did we have? We had 5 minus 2x. And then we had x. So that's all multiplied. That's going to give us our volume. And as you can kind of see, it's well, we just need to zoom in a little bit. And it looks a little different than I had, but we can see a place where there's going to be a maximum here. This would be some kind of a minimum. You can't have negative volume, but this is our solution here. So we should have a cup, thanks Sydney, of 0.87 6 if it's 2 decimal places, right? They want us to 2 decimal places. 0.86, and then the volume is the y value, 7.64. So that's the beauty of this is once you get it set up, the values are going to be using the graphing calculator. Okay. How was that? Good. Okay, let's go back and see. Oh, yeah, and I did design the course, but I don't know, out of the 187 topics, I'm not quite sure where they're all at. And again, I want to focus on the ones that are in the reviews. So if you can help me by locating question numbers in the reviews, that's going to be the best, because then sometimes functions determined as follows. Okay, look, okay. I could go back to this logarithm one. I know that's going to be, let me just submit this one. And we will find similar ones in the last review. Let's see. On expanding logarithms. Yeah, similar to that. I'll maybe go ahead and take this one from the log 3 square root of x plus 7 to the 4th divided by x to the 5th. And I'm assuming this is just a common logarithm, much like this one. So we'll do this one. We can come back to this one as well. What you have to see here when we're doing logarithms, the properties we're going to use is when you're multiplying two things inside a logarithm, right? It's going to become addition. When you're dividing, that's going to become subtraction. So what I'd like to do is identify the pieces. So this is the factors. This is a 3. This whole thing will come out as 1. Actually, you could, well, we'll deal with it in a moment. And then this is going to be another thing. And again, this is going to be, these two will be added and this will be subtracted. So we could expand it out as the log of 3 plus, and that's coming from this multiplication, the log of the square root of x plus 7 to the 4th minus, because we're dividing, the log of x to the 5th. And I find just try to do that all at one motion. The next thing we want to do is any exponents in a logarithm, they're going to come down in front and become multiplication. Now this radical, this square root, the radical is a 1/2 power. Okay. If we have a cube root, that is a 1/3 power. So what I'm going to do is I'm going to work with this one first. This will be log x plus 7. The square root is a 1/2 power, so that's 1/2 times 4. because it becomes an exponent up here. Exponents multiply together. 4 divided by 2 is 2. And so our final answer, the 2 will come in front. The logarithm is plus 7 minus the 5 comes in front of the logarithm. And the 3 is just a 3. So this is just log 3. And so this would be your final answer to expanding this logarithm. Was that helpful?
Yeah, thank you.
Okay. Question 7 of review 1 through 3. Okay, let's clear this out. Use that one. And again, remember the other thing I wanted you to see is sometimes students don't look into each of the modules. That there is a separate recorded solution video for each of these, somewhere between maybe 2 to 3. Some of them are 10 or 15 minutes long, but I walk through the whole solution process. In fact, some students have told me that they get behind, they use this and as their learning tool. So we can do that. And remember, if it's in the reviews, it potentially could be on your exam. If it's not in the review, it won't be on your exam. Okay, so the functions f and g are defined. For each function, find the domain. So in this case, what we're interested in is the only thing that can happen. There's no square roots. So domain there's 3 things that give us problem with the domain. Whenever you see the question about domain, it's asking what x values can we not calculate. Anything that makes a denominator 0. Oops, somebody's in the waiting room. I missed them. Oh, here we go. Maybe here we go. So we can't divide by 0. The other thing we can't do is if we have a square root, we can't have negatives because those are imaginary numbers. And then logarithms, case B, you cannot have 0 and you cannot have negatives. So it has only positive numbers can come in. Well, not just positive, but non-zero. Whatever's in here has to be bigger than 0. So that's what we're working with. In this case, all we're interested in, or all we have to worry about, is when would the denominator become 0. We take x squared plus 12x plus 35. When is that going to equal 0? Those are the values we would have to take out. Now you can factor this. 35 is 7 times 5. 7 plus 5 is 12. But I'm also going to show you if you've had problems factoring, the other way I would do this is I would just graph this. Maybe I'd do this first because, let's see, over here. So just take the denominator. We're going to go y equals x squared, arrow over, plus 12x plus 35. And what we're looking for is where does this become equal to 0? That's the x-intercepts. Yeah, zoom in a little bit so we can kind of see this. We're going to see one of them is at -5, the other is at -7. Okay, so what that's telling us is we cannot let x equal -5 or -7. We can draw a number line, -7, -5. Those are the things we need to exclude. Here's -infinity, here's +infinity. So we can have everything except -7 everything except -5, and after that we get everything. So the domain is going to look like this, union -7 to -5, union -5 to infinity. Okay, so it's a very complicated way of removing just two numbers that we need to remove. The other way is to see, okay, how do you factor this? This would have been x plus 7, x plus 5. You FOIL this out, you'll see you'll get this. 7 times 5 is 35. You get 5x plus 7x, that's 12x, and there we are. And then you have to do x plus 7 equals 0, or x plus 5 equals 0. Subtract 7, x equals -7. Subtract 5, x equals -5. So that's all the work you'd go to do it by hand, but that's also what we found when we just graph it. We got them right here, -5 and -7 directly. So two ways to do it. Same thing with this one. Again, you could graph it, but it's a little easier. You're just going to take x minus 4 equals 0, just one place, add the 4 to both sides. So when x equals 4, we have problems. Put a 4 here, you get a negative, or you get 0 on the denominator. And so that one, again, put it on the number line. -4 has to be excluded. So we go from -infinity to 4, and then we go, -infinity to -4, -4 to infinity. Union -4 to infinity. So that would be the answer for the second one. Does that help? Okay. That one out of the way. It's out of the way. What else? We've got about 20 minutes left. In any questions you may have, and Friday is the due date. However, there's a 2-day no cost extension until Sunday night. Part of it's psychology. I know if it's Sunday night, you know, can I have a 2-day extension? Well, you've already had 2-day extension, and it's, you know, part of it is getting the systems to work together. But also, I know trigonometry is oftentimes a new area, and I want to make sure you have time to go through that. And especially with A session, we only have 2 days after the end of A session to get grades in. So there's not much I can do as far as extending the trig part. And so it's really a course. 7.5 weeks it's a 16-week course that you're doing in 7.5 weeks. And it's really 2 courses. There's an algebra course and the trig course. So there's a lot that just needs to get accomplished in this short period of time. But I do my best to try to make accommodate various needs. What else? And just, you know, you can unmute yourself, just come in or put something in the chat. And again, it'll be easiest if we can find, if you want to see some questions, find something in one of the reviews. I can jump to those review questions. And don't worry if it's already been asked or anything. I mean, you're here. You took the time out of your life to come to this. Any questions you have is of much value as anybody else.
Hello.
Could we go over number 12 with the graphing of the vertical and horizontal asymptotes?
You got it. Uh, 12 here, or in which, do you mean module 12?
12 on the practice test.
Okay. The thing is on the practice test, that's completely randomized. So your question 12 may not be my question 12. That's why but if we go from the modules are static. See, that's rational. I'm thinking it might be in 8 to 11. Let me see if I can find one. I think I need to get out of here. This is in progress. This is what I mean. You have to submit this one. Yeah, the practice test was just a lot of students were saying, well, it's great to have all these reviews, but they wanted something that was 20 questions so they could practice the length, and that's what it's intended for. But each time it comes up, it's going to randomize the order of the questions and everything else. So it's not really helpful to go into it to try to review. Unless if you had one up, I guess, you could share your screen and I could work that way. Let me see if I can find one here.
Joel.
Asymptotes. Oh, here we go. So all vertical and horizontal asymptotes, something like this.
Yes.
Okay. So first of all, vertical asymptotes. Let's go with this. Vertical asymptotes are going to come from wherever the denominator becomes 0. So to do that one, we do 2x plus 5 equals 0. And then we solve for x. Subtract the 5. Divide by 2. So x is going to be equal to negative 5 halves, which is negative 2.5. So then we get our vertical asymptote. Let's see, how does this thing work? Oh, and then you could choose any point. So the x value is negative 2.5. And then the y value could be anything minus, well, just make it 0. There we go. I drew the asymptote. Horizontal asymptotes, there's 3 cases. There's 3 different things that could happen. Let me change colors here. For horizontal asymptotes, what you're going to look at is just the largest, or I forget what they call it, the largest exponents. So we've got an x squared here, and we've got an x, and we ignore everything else. So we pretend that we just have minus x squared over 2x. And then we can simplify this, right? X goes into x, it becomes negative x over 2. And then you just think what would happen as x gets bigger. Well, this one does not have a limiting value. As x gets bigger in either direction, this number is going to get bigger, right? So say you plug in x equals 10. Negative 10 over 2, you get negative 5. Say x equals 100, you get negative 100 over 2. That's equal to negative 50. So the values are just going up. So there is no horizontal asymptote. And this is the case whenever the degree, that's what the word I was thinking of, the degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. Now, if these both were x squared, so if we had minus x squared over 2x squared, notice the x squareds will cancel, and this would be like negative 1/2. This now is y equals, this would be our horizontal asymptote. Okay, so if the degrees are the same, you will have a horizontal asymptote. And then the third case is if the bottom is bigger than the top. So if we had negative x squared over, say, 2x to the third, when this cancels out, this becomes negative 1 over 2x. There's 1x in the bottom. As x gets bigger, this is a fraction. It's in the denominator. This is getting smaller and smaller. This is going to give us a horizontal asymptote at y equals 0. So the three cases. So case 1, no horizontal asymptote when the top degree is bigger than the bottom. That's this case. If they're equal to each other, then you get a horizontal asymptote at the ratio of the coefficients, so negative 1 over 2, negative 1/2. And if the bottom degree is bigger, and it doesn't matter by how much, but it's bigger, then the horizontal asymptote will be at y equals 0, which is the x-axis. Okay, does that make sense? Does that help?
Yes, thank you.
Okay, you're welcome. And this is the kind of thing that can get partial, like maybe you get one of the asymptotes right, and maybe you put one that doesn't belong. Then we can give some partial credit for the part that you got right. Again, Alex will just mark it either completely right or completely wrong. But those are the types of things we can get partial credit for. Okay. This is being recorded. And then once we finish, it takes Zoom a while to process it, but I will put the link to it. You mentioned for the exam, our face and hand with scratch paper must be in the camera. For me, I probably need to place the laptop in a box, get an angle. Yeah, that's, I know I've got an extra webcam that you can put that somewhere that sees it, but if you're using the webcam on a laptop, typically the best way is to elevate the laptop so that you can see it while you're working. It sees your hands and your face, and then yes, your hands are going to be out of view when you go to type in answers. That's to be expected. So it's not a perfect solution, but it's at least something that the administration, the math department, has come up with. It needs to be clear enough that you can't have a cell phone sitting over there, or other books, whatever's in the camera's view. It does need to be clear enough that it's and here's something I was able to test one out, and like even pictures behind you, sometimes the honor lock will pick that up as a person sitting behind you or something, and they might come into it. Again, not that some things get flagged, we review those, but do your best to make it a clean testing environment. Let me just put it that way. Now, if someone's got a bottle of perfume there, that's probably not an issue, but yeah, a stack of books sitting there, at least get them out of reach. Question 8 and 8 to 11. Sure, we could. Or did we do that already? Yeah, I think we did. I don't know. Maybe not. Let's see. Got it. Okay. Question 8 and 8 to 11. Let's see. Okay. No, we haven't done it yet. Okay. So this one was requested. Species of animal is discovered on an island. Suppose a population size P of t of the species is modeled by the following function, where time is measured in years. So find the population size after 6 years, population after 8 years. So we're just going to plug in 6 and 8 for the t. One way to do this is with, since you've got to find two values anyway, I would plug it into Desmos. 790 divided by 1 plus 4e to the negative 0.3 t, and what we have to use is x instead. So with x, it'll give us a graph like this. Now, oh, we're all negatives. Let's see. Well, it's getting big, so let's zoom out. I don't like when it's the color maybe red. Then what we do is we want to see what happens when we plug in 6 with population size after 6 years. So that means when x equals 6, I don't want that red, let's make that one blue. When x equals 6, I can come here and I've got the value 475.56. And they want it to the nearest whole number. So 476 for this one. And then to figure out what happens at 8, I just change this to 8. And now my graph has moved over here. And when it's 8, it's 579, so 580. Okay, sometimes these will ask, you know, when will there be 700 people? In that case, that's an output. You would graph y equals 700. And you can also find it by finding the intersection of the graph and that number. So this would be after 11.45 years. So it works either way. If we're plugging in, we put x equals, at that time, x equals 8. And if you wanted to, you could also just do it up here. Instead of putting x, you could have put, I think you might need to, since there's that 0.3, you have to do times 6. And notice we get that value here. So you didn't have to go to the graph, okay? And then you could just change the 6 to an 8. We get the second answer that way. Multiple ways to do it. That help? It was good. Okay, good. Yeah, good questions. As I go through this, I found multiple ways to do this. Great. We got about 5 minutes left. If there's no questions, that's okay. We can end early. If you've got some questions, let me know and we'll get on it. If I missed any in the chat, I apologize. 4 to 8, question 9. Let's do that. Seven, number 9. Okay, so this one's a composition. They're giving us two functions, f and g. And we're going to take both compositions, putting G into F and F into G. If they both end up being just X, then that makes them inverses, otherwise they're not. So this first one here, F of G of X, what I do is I take the outside, which is F, I take that function, which is X minus 2, I'm going to rewrite it as X minus 2. I change the X just into a big open parentheses. What goes in that parentheses? G function. G is going to go there. What is G? It's X plus 2. And then now I can simplify. So nothing around the parentheses. X plus 2 minus 2. This plus 2 minus 2, that gives us 0. We end up with just X. And then we do it the other way around. We start with the G function. We're going to put the f of x function inside it. So G is x plus 2, so I write it as x plus 2. And notice I just change my symbol to a big open parentheses. I could still call that x. What goes inside there? The f of x function, x minus 2. And then when I simplify that, I see, well, there's nothing in front of the parentheses to multiply. There's no exponent, so it's really just x minus 2 plus 2. And yes, this also equals x. And since they both equal x, that means when you put one into the other function, every function starts at x, right? F of x, where the input is x, the output becomes x. That is because one function undid the other, right? We ended up right back where we started, so this means they are inverses. And then you would do the same thing with b. And this one's maybe a little more complicated. F of x is minus 3x. So if you do f composite g of x, we're going to start with f, the outside function, which is minus 3 over x. What goes in there? The g function, which is 3 over x. Now this one, you just have sort of a fraction over fraction. I like to think of this as negative 3 divided by 3 over x. So you flip and multiply. It's going to be minus 3 times x over 3. The 3's will cancel, but there's still this negative. This equals negative x. That is not going to be an inverse. If we didn't get back to x, we got to negative x. So think of the number. If we didn't get to 3, we got to negative 3. We did not get to the same place. But the composition of these two is minus x. And I can tell you right now, that's not going to be an inverse. We would do it the other way around. We'll probably get the same thing. But even if we got a positive x there, this one value right now tells us these are not inverses. And I can see we're going to have g of x is 3 over x. We're going to plug in minus 3 over x. And yes, we'll get 3, and I'll just flip it and multiply, times x over negative 3. 3's cancel, there's still a negative, so we also get negative x for that one as well. Okay. And that takes care of that. Thank you, Michelle. And again, remember, I would go over these multiple times. You can submit these. You can, and it will do it once you get it right. You can't redo it until you get them all right. That's called a quick retake, but it allows you to keep working on the ones that you're missing. Once you get them all right, you can take them again. It will keep the higher value. So once you get to 100%, that's locked in. Don't worry about scores, but you could go back and practice with a few of them. Check your answers. And then remember that in Canvas, there are the solution videos, links to the solution videos. The videos themselves are actually on YouTube. Yes, for them to be inverses, they have to equal x, because that's where we start. We start at x, not at negative x, not at x minus 4. We start at x. We have to get back to x for them to be inverses. Otherwise, we ended up someplace else. Yes. All right. Thank you all very much. I hope you've found this beneficial. There's still time to study. And again, take the time you need it. If you need the weekend, keep doing it. It's the tests are worth 35% of the grade. So you've got to do well on the exams. You've got at least, you know, you don't have to actually pass both these. If you get all the homework done, I think you get a little bit over 50% on each of them. It's not a passing grade on the exams, but you still would end up with a C. But I'm hoping that we're not seeing the minimum we can do, but how we can do well. But scoring well on the exam is really where it's critical. And every math department I've worked in, that's been about their level, is about 70% of the grade comes from the exam itself, 30% from the homework and getting everything done. But you have to retain it well enough to do reasonable on the exams. Okay, thank you very much for being here. Thank you. Bye. So may you all have a great evening. As soon as this processes through Zoom, I will post a link to it for all your colleagues who take a look at it as well. So be well. Check in if you need anything. We keep making that progress. Take care.
Thank you. Good night.
Thank you.
Thanks so much.
Thank you.
Thank you.
Thank you.